one person asked, well, you ended basically the presentation with this question, right? Is this the holy grail to elasticity, or but the question that this person asked is this approach an everywhere applied solution, or is it just suited for just some use cases, or where do you see the best fit, basically, according to your experience?
I think we have answered that question right away.
Yeah.
It depends on the use cases, for sure.
So, but what could be a typical use case?
Well, yes, everything really, but it depends on the context. If you need something simple and you're very good with HTTP, then just go for it. This one, for instance, this Raspberry Pi, Internet of Things, is a good example of communication between devices or processes, low latencies and smaller packages, no overhead.
Okay. So another question. At this year's JOTB, a lot of talks revolve around, or at least mention, reactive design principles, event sourcing, etc. Why is this approach gaining more and more adoption nowadays, according to you?
Yeah, so to start a little earlier, I think one of the reasons, it sounds a bit dramatic at the Elon Musk level, but the CPUs are not really increasing in power that much lately. I mean, the speed increase of the clock hasn't improved much over the past 10 years or so. And that's why we miniaturize things so much that we're hitting the boundaries of light speed. So we can't put transistors too close, because then you can't distinguish if it's 1 or 0 anymore. And so the way we're going is parallelizing things. So instead of using more powerful CPUs, we're using a lot of CPUs next to each other. And when you want to work in a concurrent environment, be that a machine with like 4 or 8 or 16 CPUs or more machines, well then this reactive principle, they really help you to parallelize things and run things concurrently.
So you think we will see this more and more in the future, in wide-scale deployments in companies, because of the limitations of the processing power, let's say?
I hope so, but what I also see is that companies are just willing to, let's say, if you have a whole system based on, I don't know, Node.js or something that is not as reactive as Akka, companies often prefer to just throw maybe more money and add more machines, or rather than approaching things from an architectural perspective. But yes, I definitely hope to see this more happening.
Okay, cool. Another question that came in: can you use this architecture with processes running other technologies like Python, R, MATLAB to address computational needs when doing data analysis? So it's a lot of words, but
yeah, yeah, that's another shortcoming. I think you can have Akka that runs on a JVM, talk to an Akka process that runs, for instance, you have Akka.NET. So if you have a .NET framework, I think those two can communicate. But if you want to talk to another language or like MATLAB or something else, then you probably need to go to a higher level, like HTTP. Akka works with TCP, really a bit lower. So maybe there's some MATLAB plugin that does that for you, but I doubt it.
Right. So I hear some laughs, so probably people know more about that topic. Okay. Maybe any questions remaining from the audience? Yeah, there's someone.
Thank you. One question I have is, did you face any issue contacting with the seed nodes? Now they are behind Kubernetes. Like when you're setting the cluster in Akka, because I work with Akka and clusters, and if they are behind Kubernetes or behind the Docker, usually it's not so easy to contact with them because you need to know the IP for the seed nodes.
Yeah.
Is there any trick you use, or do you are using just well-known IPs before you try to connect with the seed nodes?
Well, what I did is you can assign to a node a specific DNS name, and Kubernetes will make sure that even if the IP address changes, but the DNS name stays the same. That's how we solved it. I think that's also Lightband mentioned this in some advice that they gave.
Hey, nice presentation.
Thanks.
I got this question because I'm not super familiar with ACA. Actually, that's the first time I heard of this.
Huh.
So I'm just wondering, how does it work that can I consider a one single actor as a worker and a message broker, or how, and the follow-up question is how the message failures are handled in this environment.
Yep. Excellent questions. So the first one, yes, you can cram as much logic as you want inside one actor and make it do everything you want, but really it's not an advisable thing to do. The idea is that really each actor really, sort of embodies this separation of concerns idea, and each actor is very, very simple, quite stupid, only able to do one thing. So that's a design approach. And then the second question, failure. Yes, ACA is really, one of the reactive principles is resilience, and the way ACA deals with failure is, first of all, the way you program things. You can never assume that a message arrives. And so you need to somehow guard yourself against that. But also, I didn't have time to go through it, but actors, all of them have a supervisor or a father, if you want. This supervisor is in charge of dealing with the failure of the children. And these concepts might seem a little strange, but what you're actually doing with this is you are separating the dealing with failures from your actual business logic. So when you work with actors, you will never ever see try-catch again, because try-catch is mixing business logic and exception handling. And what we're doing here is separating it. But it's a long question, but yeah, that's it's very well thought through.
Sorry, so I got one more question.
Oh.
So is it like a one actor we have like a one actor is per one JVM, or how? Because I'm thinking like when you, is it possible that I'm just curious, like how does it work that when I consume a message, so in the same time I have to process some job, or so I'm spawning like two processes, one for consuming messages and one for doing the job, or how does it work?
Yeah, so lots of question in one question.
That's the last one. Thank you.
Actors are very, very lightweight. One actor is very lightweight, and they get sort of multiplexed onto a thread. So if you have, let's say, 2 threads available and you have 4 actors, well, then you will have this 2 degree of parallelism, where maybe on one thread you can have multiple actors, but they will use concurrently the CPU. And their mailboxes are a linear operation, so they consume messages one at a time. And when they are done consuming that one, they will pick up the second. Then, of course, at this point, you can use futures and other things like that to trigger the processing of multiple messages, one after another. But that's all over. The idea is that you consume one message at a time, and when you're done with the first, you pick up the next one.
Okay. Any more questions from the audience? Yeah, in the back.
Hi, I have a question. So nowadays cloud solutions are very popular, right? So I think the main advantage from autoscaling would be that I don't need to physically own all the servers that would need to be able to, process all the maximum, let's say, payload. So can I integrate ACA with, for instance, AWS to actually spin up EC2 instances or some other instances that would actually serve as my workers and then only pay for the actual load? Or can I use this kind of solution with cloud-based instead of a local Kubernetes cluster?
Yeah. Actually, yes. Everywhere you can run a JVM, you can run this ACA and actor systems. I'll tell you even more. ACA, and in particular ACA cluster, were created in a time where containers and orchestrator were almost not yet invented. And so virtual machines are their prime use case. So EC2 instances are, for instance, the way people have done this for the past 5 years. Yeah.
Okay. Any last questions before we close off? No, I don't see any hands in the air. So, okay. So with that, I think some interesting questions. I would like to thank Fabio for his talk, and obviously you for coming all to this presentation. And I wish you much pleasure with the rest of the program of today. Okay, thank you very much.
Thanks.